3.4, the chain rule. If y equals f of u is a differentiable function of u, okay, so you can take the derivative of f of u with respect to u, and u equals g of x, and g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x. Alright, so this is a composite function, where you have a function plugged into a function. Let's look at this one first. This is saying the derivative of f of g of x with respect to x. Again, this is a composite function. The rule states, take the derivative of f with g of x plugged into it, and then take the derivative of g of x. Another way, so you want to get really familiar with all these different ways that you can state this. Another way we can state this, we can say the derivative of f of u with respect to x, the reason why is f of u is really equal to f of g of x because u equals g of x. So then this rule here is stating the same thing as this. You're taking the derivative of f, right, with u plugged into it, and then you take the derivative of u. An alternative way to do this is to take the derivative of u with respect to u instead of with respect to x, and then take the derivative of u with respect to x. Okay, another way you can think of this, because you could say the derivative of y with respect to u is the same thing, or multiplied by dy dx. So all of those are saying the same thing. We could go through the proof, but I don't think it's necessary for this class. Let's take a look at this one. So hopefully you can see here, this is a composition of functions here. So this function here, this 3x minus 2x squared, that is being plugged into the function x cubed, where f of g of x, the composite function, would be 3x minus 2x squared cubed. So let's take the derivative of f of g of x with respect to x, where the rule states f prime of g of x times g prime of x. So first of all, the derivative of f prime g of x. So if we take the derivative of this, okay, where this piece here is the g of x, if I took the derivative of this, we would do the power rule. So it would be 3 times g of x, which is the 3x minus 2x squared, because you do subtract 1. And then we're going to take the derivative of this, which is g of x. The g prime of x would be 3 minus 4x. That would be the derivative of f of g of x with respect to x. Let's take a look at another one. So first of all, you have to be able to recognize that it is a composite function, or a composition of functions. And this is, again, let's see if we can find f of x and g of x, where f of g of x equals x squared plus 1 cubed. So the function that's being plugged into the cubic function is this x squared plus 1, and that's being plugged into x cubed. Again, the rule to find the derivative of f of g of x with respect to x is f prime of g of x times g prime of x. Where f prime of g of x, if I take the derivative of this using the power rule, it's going to be 3 times x squared plus 1 squared, and then I have to take the derivative of g of x, which would be the derivative of x squared plus 1, which would be 2x. Then I could simplify this a little bit. I could make this 6x times x squared plus 1 squared. That would be the answer there.